The polar lights. The beautiful harmonized composition of color. Aurora. Hello everyone. This is AWZ. Welcome to our channel. Don't forget to subscribe. Enjoy. Aurora. An aurora is a natural light display that shimmers in the sky. Auroras are only visible at night and usually only appear in lower polar regions. An aurora is a natural light display that shimmers in the sky. Colorful blue, red, yellow, green, and orange lights shift gently and change shape like softly blowing curtains. Auroras are only visible at night and usually only appear in lower polar regions. Auroras are visible almost every night near the Arctic and Antarctic circles, which are about 66.5 degrees north and south of the equator. In the north, the display is called Aurora Borealis, or Northern Lights. In the south, it is called Aurora Australis, or Southern Lights. Auroras and the solar wind. The activity that creates auroras begins on the sun. The sun is a ball of superhot gases made up of electrically charged particles called ions. The ions, which continuously stream from the sun's surface, are called the solar wind. As solar wind approaches the Earth, it meets the Earth's magnetic field. Without this magnetic field protecting the planet, the solar wind would blow away Earth's fragile atmosphere, preventing all life. Most of the solar wind is blocked by the magnetosphere, and the ions, forced around the planet, continue to travel farther into the solar system. Although most of the solar wind is blocked by the magnetosphere, some of the ions become briefly trapped in ring-shaped holding areas around the planet. These areas, and a region of the atmosphere called the ionosphere, are centered around the Earth's geomagnetic poles. The geomagnetic poles mark the tilted axis of the Earth's magnetic field. They lie about 1,300 kilometers, 800 miles, from the geographic poles, but are slowly moving. In the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from the Earth's atmosphere. The energy released during these collisions causes a colorful glowing halo around the poles, an aurora. Most auroras happen about 97 to 1,000 kilometers, 60 to 620 miles, above the Earth's surface. The most active auroras happen when the solar wind is the strongest. The solar wind is usually fairly constant, but solar weather, the heating and cooling of different parts of the sun, can change daily. Solar weather is often measured in sunspots. Sunspots are the coldest part of the sun and appear as dark blobs on its white-hot surface. Solar flares and coronal mass ejections are associated with sunspots. Solar flares and coronal mass ejections are sudden, extra bursts of energy in the solar wind. Sunspot activity is tracked over an 11-year cycle. Bright, consistent auroras are most visible during the height of sunspot activity. Some increased activity in the solar wind happens during every equinox. These regular fluctuations are known as magnetic storms. Magnetic storms can lead to auroras being seen in the mid-latitudes during the time around the spring and autumnal equinoxes. Auroras have been visible as far south as the Yucatan Peninsula in Mexico. Magnetic storms and active auroras can sometimes interfere with communications. They can disrupt radio and radar signals. Intense magnetic storms can even disable communication satellites. Coloring an aurora. The colors of the aurora vary depending on altitude and the kind of atoms involved. If ions strike oxygen atoms high in the atmosphere, the interaction produces a red glow. This is an unusual aurora. The most familiar display, a green-yellow hue, occurs as ions strike oxygen at lower altitudes. Reddish and bluish light that often appears in the lower fringes of auroras is produced by ions striking atoms of nitrogen. Ions striking hydrogen and helium atoms can produce blue and purple auroras, although our eyes can rarely detect this part of the electromagnetic spectrum. When is the best time of year to see the northern lights? The Aurora Borealis are potentially visible under dark skies from late August to mid-April, preferably under a clear, cloudless sky. While they occur year-round, they are weaker than sunlight and therefore sightings aren't possible from May to July and for most of August. Spring and autumn generally provide more stable weather conditions and milder temperatures, plus there is greater aurora activity around the equinoxes. November through to February offer the darkest skies and longer evenings for maximum skygazing. The strongest lights tend to appear between 9 p.m. and 2 a.m., though the best sightings often occur between 11 p.m. and midnight. Between 4 a.m. and 5 p.m. there is generally too much daylight to see the aurora. Exceptions are the darkest months of the year and higher latitudes such as Svalbard, where it is dark 24/7 from mid-Nov to end of Jan. Where is the best place to see the northern lights? The northern lights most commonly occur within the geographic area beneath the auroral oval. It encompasses latitudes between 60 and 75 degrees and takes in Iceland, northern parts of Sweden, Finland, Norway, Russia, Canada, and Alaska, as well as southern Greenland. The map graphic shown here is indicative of where the aurora are most visible, but they can appear at lower latitudes. Particularly strong solar storms can result in the lights being seen in Scotland and northern England, though most aurora activity occurs within the oval, hence its designation. However, aurora activity is not consistent in the auroral oval. The appearance of light as a ring around the poles constantly shifts. Therefore, strong aurora in Sweden do not necessarily mean strong aurora in Canada and vice versa. The oval is tracked by space weather stations and is shown in forecast modules. Northern Scandinavia and Iceland offer the most accessible destinations from the UK for viewing the northern lights, but there are recognized locations throughout the zone that offer optimum conditions for sightings. It is important to be away from any sources of artificial light, such as street lighting, whereas you do want to be near open spaces offering big sky viewing. Ten cool facts about the northern lights. 1. The Aurora Borealis continuously adopts new forms. The ever-changing flow of charged particles and the constantly shifting magnetic fields are what give auroras their distinctive patterns and configurations. The beams move over the sky in a dancing motion, sometimes moving quite quickly. At high latitudes, magnetic field lines are nearly vertical, which explains why auroras appear to be near vertical streaks of light. Auroras are the optical traces of electrical currents flowing up and down the magnetic field lines. The particles of plasma in the aurora are moving in response to the magnetic field of the Earth, which causes the aurora to look like curtains of light that are moving. 2. The phenomena known as the aurora was originally characterized and explained by a researcher from Norway. People have been captivated by the breathtaking spectacles that can occasionally be seen lighting up the night sky for thousands of years. There have been hundreds of myths and hypotheses written to try to explain what we now know to be auroras. Auroras were once regarded to be omens of impending disaster. However, until roughly 100 years ago, nobody thought that there was a connection with the sun. The Norwegian scientist Christian Birkeland, 1867 to 1917, was the first to explain the origins of the aurora, and as a result of his discovery, an entirely new field of research was established, the relationship between the sun and the Earth. 3. In the year 1619, the name Aurora Borealis was first used. The name for the phenomenon known as the Northern Lights is Aurora Borealis, which comes from the Latin word for the Roman goddess of dawn known as Aurora and the Greek name for the north wind known as Boreas. However, there is some disagreement as to which astronomer, Pierre Gassendi, 1592–1655, of France, or Galileo Galilei, 1564–1642, of Italy, was the first to give them their names, 1564–1642. 4. The Southern Lights were given their name, Aurora Australis, by Captain James Cook. Following his exploration of the Antarctic in Resolution, Captain James Cook gave the same occurrence in the Southern Hemisphere the name Aurora Australis, 1772-75. The name Australis originates from a Latin word that literally translates to southern. 5. The first documented sighting of the Aurora Borealis dates back to 2600 BC. Archaeologists are under the idea that certain impressionistic cave paintings portray northern and southern lights in the sky. The first documented reference to the aurora was made in China in the year 2600 BC, and the text read as follows: Fu Pao, the mother of the Yellow Empire Xuan Yuan, observed intense lightning moving around the star Su, which belongs to the constellation Beidou, and the light filled the whole area. The oral histories of Australia's indigenous peoples include references to the Aurora Borealis. The Aboriginal people and the Native American societies have many parallels, including their interpretation of auroras as symbols of fire, death, blood, and omens. 6. There are countless accounts in written form of the phenomenon known as auroral sound. Less well known are the unexplained reports of sounds that were heard during auroral displays. Many reports indicate a hissing sound followed by a sharper crackling or clapping sound was heard during auroral displays. Auroras are renowned for their spectacular light shows, but less well known are the reports of sounds that were heard during auroral displays. 7. Red and green are the most frequent colors seen in the Aurora Borealis. The hues of the polar lights are determined not only by whether or not electrons hit with oxygen or nitrogen, but also by the amount of energy that these collisions produce. The combination of oxygen and nitrogen results in the production of purple, pink, and white light. Oxygen gives off a light that is either greenish-yellow or red, while nitrogen typically emits a blue light. Because of the heightened sensitivity of our night vision to green light, we are more likely to notice the oxygen green line emissions. Nitrogen auroras can appear blue at times, or a color that is a combination of blue and red, purple. Some of the nitrogen emissions produced by the aurora are in the ultraviolet region of the spectrum, which is invisible to us. 8. This one's only for the night owls. Even though auroras are more likely to appear around the equinoxes, which occur in late March and late September, displays of the phenomenon can take place at any time of the year. Because the evenings are longer throughout the winter months, this is a naturally good period to observe the northern lights. The most brilliant displays normally last between 1 and 3 hours, and the ideal times to observe them are frequently between the hours of 10 o'clock at night and 2 o'clock in the morning. However, there is no golden hour during which you are certain to view the northern or southern lights. Instead, avid aurora hunters normally keep a close check on our real-time geomagnetic indices, which indicate the intensity of geomagnetic activity, and are willing to remain up all night if necessary. 9. Auroras have been spotted in southern Queensland, which is located in the far north of Australia. The term auroral oval refers to a ring that is centered on the magnetic pole of the Earth and contains the highest concentration of auroras. During a geomagnetic storm, this ring of light moves closer to the equator and grows larger than it is normally when it is located above the Antarctic and subantarctic regions. Because of this, auroras can be seen most clearly from our southern coasts, and they are typically located rather close to the horizon. However, during times when the Earth is most influenced by activity on the Sun, they are able to be seen at lower latitudes. These times are known as solar maximum and solar minimum. Rarely, auroras have been spotted in Australia as far south as Queensland, which is located in the far north of the country. 10. Auroras are not unique to the planet Earth, other planets also have them. Auroras are not exclusive to Earth. They may also be seen on Jupiter, Saturn, Uranus, Neptune, and Mars, among other planets in our solar system. The lights, which have been detected near to the magnetic poles of other planets, have been compared to the aurora on Earth. This is all for now. Check out other videos on our channel. Enjoy.